Next, chapter 1 GTD for semester electrical solar power plant. A solar power plant is any type of facility that converts sunlight either directly like photovoltaic or indirectly like solar thermal plants. Photovoltaic power plant use large area of photovoltaic cells known as PV or solar cells to directly convert sunlight into usable electricity. These cells are usually made from silicon alloys and are the technology most people have become familiar with. Chances are you may have one on your roof. These cells are usually made from silicon alloys and are the technology most people have become familiar with. Chances are you may have one on your roof. The panels themselves come in various forms. Crystalline solar panels. As the name suggests, these type of panels are made from crystalline silicon. They can be either monocrystalline or polycrystalline or multicrystalline. As a rule of thumb, monocrystalline versions are more efficient, about 15 to 20%, but more expensive than their alternatives. Tends to be 13 to 16% efficient, but advancement are closing the gap between them over time. Thin film solar panels. These type of panels consist of series of films that absorb light in different parts of the electromagnetic spectrum. They tend to be made from amorphous silicon Si, cadmium telluride CDT, cadmium sulfide CDS, and copper indium gallium diselenide. This one shows the block diagram of a solar power plant. Here this one is the solar panel which is mounted on the roof of a house or a building, and this one is the battery, and this is the inverter which convert DC to AC. This one is meter box and fuse. These are the home appliances. This is the grid. So whenever the solar panel will be charged, it will give energy to the battery and simultaneously give supply to the inverter. The output of the panel is DC in nature. The DC output whenever reaches at the inverter, the function of inverter convert DC into AC power. And some of the charges also given to the charge the battery. And the output of the inverter is AC, and AC supply is directly given to the meter and fuse box. And then the meter and fuse box are directly connected supply to the home appliances like electric bulb and computers. And rest part of the meter and fuse box are given to the grid through different transmission lines and transmitter towers. Working principle. Most solar PV panels are made from semiconductor material, usually some form of silicons. When photons from sunlight hit the semiconductor material, free electrons are generated, which can then flow through the material to produce a direct electrical current. This is known as the photo effect in physics. The DC current is then need to be converted to alternating current AC using an inverter before it can be directly used for feed into the electrical grid. Next, chapter 2. This is electrical branch GTD chapter 2. Name of the chapter is overhead conductors. Faculty A.R. Naik. The most first article is the most economical size of the conductor. It has already been shown that maximum stress in a cable occurs at the surface of the conductor. For safe working of the cable, dielectric strength of the insulation should be more than the maximum stress. Rewriting the expression for maximum stress, we get G max is equal to 2V by D log base E D by D volt per meter. The values of working voltage V and internal sheath diameter D have to be kept fixed at certain values due to design consideration. This leaves conductor diameter d to be the only variable in experiment 1 for experiment 1 for given values of V and D. The most economical conductor diameter will be one for which G max has a minimum value. The value of G max will be minimum when D log base C d by d is maximum. That is d by d of d, d log base C d by d is equal to 0. That implies log base C d by d plus d by d minus d by d square is equal to 0. That implies log base C d by d minus 1 is equal to 0. Log base C d by d is equal to 1, d by d is equal to d by d is equal to e to the power 2.718. The most economical conductor diameter R and is the value of G max under this consideration. G max is equal to 2 by 2V by d volt per meter. Putting log base C d by d is equal to 1 in the expression 1. Next, corona. When an alternating potential difference is applied across two conductors whose spacing is large as compared to their diameters, there is no apparent change in condition of atmospheric air surrounding the wires if the applied voltage is low. However, when the applied voltage exceeds a certain value called critical disruptive voltage, the conductors are surrounded by a faint violet glow called corona. The phenomenon of corona is accompanied by a hissing sound, the production of ozone, power loss, and radio interference. The higher the voltage is raised, the larger and the higher the luminous envelope becomes, and greater are the sound, the power loss, and the radio noise as factors affecting corona. The phenomenon of corona is affected by the physical state of atmosphere as well as by the condition of the line. The following are the factors upon which corona depends. First one is atmosphere. As corona is formed due to the ionization of the air surrounding the conductors, therefore it is affected by the physical state of the atmosphere. In the stormy weather, the number of ions is more than normal, and as such corona occurs at much less voltage as compared with fair. Second one is conductor size. The corona effect depends upon the shape and conditions of the conductor. The rough and irregular surface will give rise to more corona, because unevenness of the surface decreases the values of breakdown voltage. Thus, a stranded conductor has irregular surface and hence gives rise to more corona than a solid conductor. Spacing between the conductors. If the spacing between the conductors is made very large as compared to their diameter, there may not be any corona effect. It is because larger distance between the conductors reduces the electrostatic stresses at the conductor surface, thus avoiding corona formations. Adding the desired number of disks. Then line voltage. The line voltage greatly affects corona. If it is low, there is no change in the condition of air surrounding the conductors, and hence no corona is formed. However, if the line voltage has such a value that electrostatic stresses developed at the conductor surface make the air around the conductor conducting, then corona is formed. Important terms. The phenomenon of corona plays an important role in the design of an overhead transmission lines. Therefore, it is profitable to consider the following terms much used in the analysis of corona effect.